Good morning, everybody. So I'm Angelo de Caro. I'm a cryptographer at IBM Research at Zurich. And today, with Maria, we'll talk about the effort that we are doing for zero knowledge in Hyperledger Fabric. So let me set the stage first and talk about Hyperledger. It's essentially a consortium of multiple companies that aims to improve and extend the knowledge about blockchain systems, especially targeting the enterprise world. There are really many companies participating in this consortium. It's very big. It's very interesting, and it does not contain just a single project. Actually, it's a set of multiple projects that target the blockchain for enterprise from multiple angles. So it's very interesting. One of these projects is Hyperledger Fabric. So everything started with IBM decided to invest in blockchain technology. So the first project actually was called Open Blockchain. Was developed inside IBM, and then we decided to open source it completely, and then it became Hyperledger Fabric. It's now a community project. It's an open source project. IBM is just one of the contributors of the project. What is Hyperledger Fabric? It's a permissioned blockchain system targeting enterprise application. So it's very important. It's permissioned. We don't target permissionless blockchain. So the participants needs to be clearly identified in the system. Though sometimes we won't allow them to hide their identity. So we want to recognize them as proper member of the network, but still we might want them to hide their true identity. It's a very big project. There are many participants, and I invite you to look at it and contribute. So what we want to enhance Hyperledger Fabric with a token management system. So probably you are already aware of what is it. So essentially, we want to have a way to manage tokens in the system of different kinds, different values. So we don't want to dictate what they should represent. Can they represent anything? We want to have the version like it's completely in plain text. We want to have a version that completely obfuscates what you are transacting, who are the transactors, and so on. But what we really want for enterprise application is the ability to an auditor to come and say, oh, now I want to see this transaction. Was the originator, was the receiver, how much, which asset has been exchanged, because this might be important to find out money laundering and other. So at the end, to go to court and say, hey, this guy did this. These things. Of course, we want to have this we want to avoid as much as possible single point of failures. So we will deploy threshold crypto as much as we can. So probably you can understand. Of course, we want to have this in a modular way. We don't want to stick to a single technology. We want to be able to deploy snarks or snark proof. So we don't really want to bind ourselves to any specific technology. So we found this workshop absolutely important because will allow standards, will allow our clients to do risk assessment, and to better develop confidence in this technology. So from our side, there will be the maximum possible push for having this technology implemented. And now let me pass the word to Maria, and she will explain more in details.
Hi, everyone. I wanted to basically now discuss how we bring anonymous authentication, anonymous credentials to a permission blockchain with the identity mixer. As many of you probably heard about, identity mixer has been around for like tens of years now. And basically, it's an anonymous credential system that allows using zero knowledge proof and allows to, instead of showing a credential, rather prove in zero knowledge that you have a credential with certain attributes by selectively revealing attributes. And you do it in a linkable way, so if you do it twice, you're completely unlinkable. So now we are in a permissioned blockchain setting. So every member of the blockchain gets so-called enrollment certificate that kind of certifies his identity and some of the attributes. And now it is identity mixer credential. So now when the user wants to transact and sign certain submit a transaction and then sign it by authenticating himself, So instead of attaching a certificate in the clear to the transaction like one would do with X509, it instead creates a zero-knowledge proof that he has a valid enrollment certificate issued by a Fabric CA or any CA, then the verifier, which would be like a validating peer in the case of Fabric, but in general it's any verifier, can verify the zero-knowledge proof with respect to the CA's key. So basically, we are integrating it in Fabric, so this is done kind of out of the box in Fabric when you submit transactions. And we also do it in a modular way, so we introduce like MSP interface that allows you to plug in different systems, like either it's 6509 or it's IDEMX or some other system that by implementing this interface would allow to transact on Fabric in a linkable or unlinkable way. So the features that are coming soon will be a selective disclosure, so you can selectively disclose attribute from your credential, and also we implement revocation because it's like one of the key features. So with the components, we basically have a component that implements MSP in Go, and that will be used by the verifiers. We integrate also in Fabric CA, which is also Go, and we'll provide, the first will be the Java SDK that we target. A second thing that I wanted to talk about, maybe Nathan will talk also about that, so I will make it shorter. So that's the effort that we're doing, with also Jason and Nathan, like with Sovereign Foundation and Everneem. It's about how to basically go down the stack and specify what we want to prove. Because when the prover talks to verifier, on the high level, we want to let them specify what they want to prove in a very high level language. And there is some effort specifying in the identity space, for example, it's verifiable credential effort that is W3C working group is perceiving. So you specify it in a very high level language, prove me that you're over 18 and so on. But then at some point you need to basically compose the zero-knowledge proof, right? And if the statement is very complex, you would probably use different building blocks like encryption, range proofs, and so on. To basically compose the zero-knowledge proof. So how do you bridge this high-level description of the statement with actually the cryptographic proof that you're creating? And you do that with the ZK-Lang specification that we defined that kind of bridges this gap between high-level description and cryptographic proof. And then when one implements this kind of compiler, it would parse this specification and then talk to the building blocks to basically compose a zero-knowledge proof. And we do it here in like this slide is more context of identity, but of course this is applicable to any zero-knowledge proof that you want to compose, basically. So, and I guess maybe Nathan would talk more also about this effort. So with that...
Just last thing, so we will demo some of these technologies next week in New York for the Consensus Conference. So if you are there, please come. Yeah, please come. We will demo the token asset management with tokens. And private transaction, new features that are coming to Fabric. So this will not be like in the very next release, but soon. The Untitled will... it's already like as experimental was released. The basic functionality was already released in 1.1. So please, contribute and see you maybe at Consensus. Thanks.